You know, one of the biggest challenges in AI isn't just about raw computing power, it's about wisdom. How do you build a machine that doesn't just parrot back facts, but actually learns to think? So today, we're going to pull back the curtain and explore the real craftsmanship that goes into training an AI that can genuinely understand.
So let's dive right in. To really get a handle on this, imagine for a second that we're teaching a student. But this isn't your average student. It's a super powerful AI. Our job is to transform it from a simple memorizer into a true problem solver. And this challenge, it's right at the heart of creating intelligent, reliable systems that we can actually trust.
Okay, so the first big problem we run into with our AI student is a pretty common one. It's an absolute whiz at cramming for a test. It can memorize the entire textbook, every single example, perfectly. But the second you give it a new problem, something it's never seen before, it just completely falls apart. It's learned all the answers, but it hasn't learned the lesson.
Now, in the world of machine learning, this memorization problem has a name. It's called overfitting. On the left, you see what we're aiming for, a model that gets the general idea, the underlying pattern, so it can make smart guesses on new stuff. But on the right, that's an overfit model. It's traced the training data so perfectly that it's completely lost the plot, making it pretty much useless for anything new.
So how do we fix this? Well, as the teacher here, you can't just toss a textbook at your AI student and hope for the best. First, you have to design the classroom. You have to set the conditions for success before any of the learning even begins.
And these classroom conditions have a name. They're called hyperparameters. Now, these aren't the things the model learns on its own, like all the tiny connections it forms inside its neural network. Nope. Hyperparameters are the high-level rules the teacher, that's you, sets to guide the entire training process from the outside.
Let's break this down with our student analogy. The number of epochs is like deciding how many times the student should read the textbook. Too many times, and they'll just memorize it word for word. The batch size is basically the size of their study group, and the learning rate, that sets the pace of the class. It controls how big of a conceptual jump the model takes with every new bit of information.
Okay, but here's the thing. A great classroom setup is only half the battle. A truly great teacher also needs to enforce some rules during the lesson to build good study habits. This is all about preventing our AI from taking the easy way out by just memorizing and instead pushing it toward real understanding.
In AI, these rules are called regularization techniques, and their entire job is to add constraints or penalties during the training process. By doing this, they stop the model from becoming overly complicated and force it to find the simpler, more general patterns in the data, the stuff that actually matters.
One of the most brilliant techniques, honestly, is something called dropout. Imagine a teacher who, instead of always relying on the same two smartest kids in the class, randomly calls on different students to answer. Dropout does exactly that inside the AI's brain. It randomly switches off some of its little processing nodes, its neurons, during training. This forces the whole network to become more resilient and not just depend on a few key pathways to get to the answer.
Now, check out this chart. This illustrates another key technique called early stopping. You can see the model's performance on new problems actually peaks at around 100 study sessions, or epochs. After that, its accuracy starts to drop. It's basically overstudying and getting confused. So early stopping is like ending the semester right at that peak performance, capturing the AI when its knowledge is at its sharpest.
So we have our classroom conditions, the hyperparameters, and our study rules, regularization. But wait, with all these countless combinations of learning rates and dropout settings, how in the world does a teacher find that perfect recipe? I mean, trying them all by hand would take forever. The good news is we can automate this search.
This whole process is called hyperparameter tuning. It's pretty straightforward, really. First, you define all the possible options you want to test out. Then you pick a search strategy. After that, the system just goes to work, automatically running experiment after experiment, testing all these different combinations, and finally, it comes back and tells you which one was the winner.
And of course, there isn't just one way to do this search. As you can see here, every method has its trade-offs. You've got random search, which is super fast but might miss the best option. Then you have things in the middle, and all the way at the other end is grid search, which is incredibly thorough. It tests every single combination, but man, it can be slow and expensive to run. The right choice really just depends on the problem you're trying to solve.
So, why are we going through all this trouble? Why does all this meticulous work, setting up the classroom, enforcing the rules, finding the best teaching strategy, why does it actually matter? It's not just about trying to squeeze out a slightly higher score on some test. At the end of the day, this is all about trust. All this careful craftsmanship is what takes the model from being this fragile thing that just memorizes into a robust problem solver. It's how we build an AI that can take what it's learned and apply it to the messy, unpredictable real world, a tool that we can actually count on.
And that kind of leaves us with a much bigger question, doesn't it? We've just been talking about the technical rules for teaching an AI how to understand data. But as these systems get more and more powerful and woven into our lives, it forces us to ask, what are the right rules, the right values for teaching them about our world? That's the real question we're all going to have to answer together. Thanks for joining me.